Hi, so here we see the homepage for Start, which is quite coincidentally start.atmel.com. All right, so you're presented with a lovely modern fonted page, and you have two prominent choices right now between where you want to begin. We can either create a new project or browse new examples. What I'm going to do first, I think, just to show you, kind of, give you the quick overview of Start, is do create new project. And although this seems to be somewhat intimidating at first blush, we will quickly isolate it down. Over here we have the comprehensive list of all the microcontrollers that are supported in Start currently, and we are continuing to add to that. Let me choose an 8-bit device, an Atmel 128, and create new project. Now we're into the basic structure or architecture of Atmel Start. With my project, and along the left-hand side now we have some dashboards, but perhaps the most compelling to start with, and this is certainly one of the things that as microcontrollers become more complex and start adding a lot more peripherals multiplexed over pins, certainly the allocation of pin functions has been a bit of a nightmare to flip through hundreds of pages of data sheets. Well, now we have something wonderful called the PinMux tool, which again now provides you with a graphical representation of the pins available of that part, and the ability to assign pin functions by pointing and clicking. So, excuse me. So I'm going to go down here, and I'm just going to select a pin at random, PE4, which would be port E pin 4 for those of you familiar with microcontroller parlance. And down here we get a bit of a description of its pin 6 on the Mega 128, and it is currently set to no pin mode and is not associated with any software component. I can go down here, and now I can select, I can give it a function, and I'm just going to turn it into a digital input. Now I've assigned, that particular pin, and I can also give it a name. I'm just going to call it input 1, and return. And now I now have a pin configured as an input, and this information will be used as the back end, in the back end, as I can generate code. Clocks are another important thing, and again, as microcontrollers become more complex, what is known as the clock tree. And it's called the clock tree because if you look at the diagram, and if you turn it sideways, you kind of get a tree-like structure, because everything from the root of the clock tree starts from the clock source, be it an external oscillator or an internal RC oscillator. And it's the routing of the branches of the clock signals that can become very cumbersome at times. And here we see, again, a graphical representation of the actual available oscillators. So the clock signal here moves from left to right, and we have what oscillators we have available. And right now, the input clock is just taking advantage of the internal 8 megahertz RC oscillator of the device. I can change that, but actually, I'm just going to leave that now, because this oscillator now is feeding into another block, which allows me to further. Oh, here, sorry. There's where the. I'm just actually, yes. My apologies. What I wanted to show you is this input clock is being fed into the CPU clock, and also what's the clock, the I/O clock, which is within the the AVR, the Mega AVRs. We can clock the core and the peripherals at different frequencies, and you may ask why would you want to do that. There are reasons for that in power consumption, which is beyond the scope of this current little chat we're having right now. I'm going to actually change the async. Hang on. Nope. What I wanted to do was change the clock frequency. I'm going to come back to that because I'm going to add some peripherals. So the other part is I'm going to go back to the dashboard, and now I can add a software component. And under middleware, I selected middleware. You can see a large amount of selections of pre-built, pre-configured code that I can add to the project. And at the end of the day, as you build your project up, you can go view code, and this will generate a large number of C and header files that you can preview, and then after you've done that, you can export the project down to your local machine. Okay, so much like MCC and MPLab Express, it's a complementary function within Atmel Start, and then these projects are completely loadable by Atmel Studio. All right.